Good day, ladies and gentlemen. This is Sarah van Grennen, aka Mr. VG, and today is a very important video specifically about equations of straight lines. Now, this is kind of where we blur the lines between analytical geometry and normal algebra. And I fully understand why you are kind of going, sir, but isn't this the same questions they ask in algebra? Yes, it basically is the same questions. But yet we have to look at them because it's going to be asked, or it could be asked as part of analytical geometry. So let's start with a question. This question specifically. Determine the equation of the line passing through A, 4, -3, and T, 8, 5. When we look at this sum, it's always good to start at where you want to go and kind of backtrack from there. So get your destination and strategize. So when we look at our destination, we need the equation of a line. Y equal mx plus c. This means that I've got to determine first of all the gradient, which I could do by either going delta y over delta x, or with parallel lines, or with perpendicular lines. That's the only three options we've got at this moment. Secondly, what do we have? So where do we want to go, but what do we have? I can go the route of changing y over changing x because I've got the 2 points. I can use y2 minus y1 over x2 minus x1. By using this, I get the gradient as being 2. Then we've got to start strategizing. How do I get c? To get c is now a different story. But for that, we can use any set of coordinates. So in other words, let's just think for a moment where we are. To get m, I've got 3 options. Changing y over changing x, parallel lines or perpendicular lines. To get c, I just need a set of coordinates. I'm choosing 8, 5 for the simple reason that there's no negatives in there. So you could use the 4, -3 and get the same answer. So I'm going to substitute that into x and y, and I'm going to determine a value for c. So c is -11. But what was the question? The question is not determine m or c. The question is the equation of the line. So the equation of the line is 2x, y equal to 2x minus 11. Ta-da! Simple and as easy as that. But what if they make life a bit more difficult? What if they give it to you like this? Determine the equation of the line that is perpendicular to y equal -x plus 1 passing through the point -2, -1. Now we've got to think. Let's start again. Equation of a line, y equal mx plus c. I've got 3 options with m. Two sets of coordinates, perpendicularity or parallel lines. I'm going to use perpendicularity. And I'm going to need that line. But what about that line? Let's hold on for a moment. That line, the y is already on its own. So I can read off the m value and the c value. That is simple and straightforward. I'm not going to worry again about the c value because I need the m value because they say it's perpendicular to that line. And I'm going to need that set of coordinates to get C. So this means I'm going to follow my basic processes. First of all, I'm going to go to perpendicularity. I'm going to substitute the gradient that I've got in, and I'm going to determine the value of the new gradient. So that new gradient's value is 1. So secondly, I'm going to use the set of coordinates given and substitute it in to get the C value. So C is going to be equal to 1. Lastly, I'm going to finish off my sum. So y is equal to 1x plus 1, or simply x plus 1. Ladies and gents, this is really, really crucial that you get a hold of this and you understand this, that you see how we work with perpendicularity, with parallel lines. Man, it is crucial. So have a beautiful afternoon, beautiful evening. Please tune in for the next videos, which is almost the most important ones. Because what we are going to look at is we are going to look at taking all of this together and look at how will it be asked in the actual exams. So stay tuned for our next 2 videos or so where we will look at that. Have a beautiful, amazing rest of your day. Keep well. Cheers.